Welcome to the webinar that we're hosting today called How to Build and Deploy a Machine Learning Solution in 4 Easy Steps on Cloudera. Just to remind you that you are on mute throughout the presentation, but if you do have questions, you can ask them in the GoToWebinar console, and we will get to them at the end of the meeting. We will also be popping a couple of polls throughout the presentation, so please make sure to answer those as we're going through. And finally, we'll be sending out an email later this afternoon with a survey. Please fill that out, and at the end of that, you'll be given access to an ebook that goes into detail on the solution we're presenting here today. So cool. Without further ado, let's move on to our introductions. And so, Keith, let's start with you.
Thanks, Jordan. Hi, everyone. I'm Keith Smith. I'm a solutions engineer here at phData. I help multiple customers through their machine learning journey, have background a lot in Cloudera architecture and data warehousing, and just happy to present to you here today. Jordan?
Thanks, Keith. And my name is Jordan Birdsell. I'm the head of machine learning services at phData. And my team's focus on helping customers find success with data science and machine learning, from the infrastructure side all the way over to architecture, engineering, model deployments, and ongoing operations. And so what we plan to cover today is, quickly we'll introduce phData, the company that Keith and I work for. We don't want to spend a lot of time on that, but we're going to touch on that. And then Keith is going to jump in with an overview of the Cloudera platform as it applies to the solution we're going to present today, as well as any other tools in our architecture. And then he's going to outline kind of the problem and solution, set that up so you understand what we're going to solve, and then he'll demo that, and then we'll open it up for questions. And so with that, let's go on to the next slide. Next. And so at phData, we're a consulting company. We're the largest pure play services provider for big data, data engineering, machine learning. And so we focus in three main areas. One is data platform administration. So this would be like your Cloudera stack, if you will, and managing that, keeping it running on a 24/7 basis, 365. The other area of focus for us is our data engineering and architecture space. And so this would be building data ingestion applications, business intelligence applications, any type of application that you might want to build on your big data application outside of machine learning. And then the final area, again, is my area where we're focused on machine learning and ML ops. And this would be anything from training the models to deploying them, monitoring them, and so on. We're going to pop a quick poll, so if you wouldn't mind answering this question, and then we'll give you just 15 seconds or so. Great, thanks for answering that. And I'll turn it over to you, Keith.
Oh, thanks, Jordan. Yeah, and thanks for the poll. So as we had overviewed, we kind of want to go over some of the typical platform and tooling that we see our customers use to do specifically edge, like an edge IoT device to get data into the platform. What types of tools on the platform that they will use, as well as what types of tools they'll use to do the ML model training, things like that, and deployment. So with no further ado, to get into this, to give a little bit of background with Cloudera, they have a couple of new tools that I wanted to present, and that will also be demoed after this. So a brief introduction to something that is newer on the Cloudera platform is Edge Flow Manager, which allows us to essentially manage and version edge devices. And this is something that can be very complicated. it can have multiple different packages. It can run on different types of machines. It can have different workflows depending on what type of environment you're in, whether that's like a manufacturing line or a telephone conferencing line. It could be anywhere that's out on the edge designed to get this in. And what this is trying to do is basically give you a tool set that allows you to manage the full flow of the life cycle of the edge application.
Yeah, and just to add a little bit of color here, this is really important for IoT applications, not just machine learning IoT applications, but if you've done an IoT application in the past, you've probably experienced the challenge in managing application deployments on the edge and working with IT departments within a factory, and it's just challenging. And so this tool gives an easy way for pushing binaries and other artifacts out, as well as managing data collection.
So that got the data gets the data from the edge device or edge platforms, and now we want to put that into a centralized repository. And the combination of what you saw on the previous slide was MiNiFi. It runs a smaller, scaled down version of NiFi, which is what you see here on the left. And what NiFi does is it gives you a nice little graphical interface to help build some of these pipelines. You can basically take that data that you're getting from the edge device, that MiNiFi device, and then do a lot more manipulation on top of it. And then to help with the DevOps lifecycle of these workflows, Apache NiFi registry has also been added to the platform. This allows us to easily version and promote, if you want to, like from lower environments to higher environments when you're doing development work, both MiNiFi and NiFi workloads. And we'll show you that when we get to it. And with that, we have a second poll that we'd like to get your feedback on what type of tools you guys use for doing ingestion ETL. Awesome. So a lot of NiFi, I guess a lot more other. Could be curious to hear what you guys use, and then some Talend Informatica. Very good feedback there. Good to know. Our customers use a variety of all of these, so we definitely are familiar with those. So once the data is in a centralized location, we want to be able to share this easily. And since this data is coming from IoT devices or manufacturing plants, this is going to be data that's basically streaming in. And the perfect tool to handle our streamed data sets is Kafka. This has become prevalent throughout all, kind of the backbone for all stream processing in pretty much every platform now, because it scales very nicely. It basically has very good security in terms of allowing people to see different topics. And it also allows you to kind of go like a microservices approach towards different applications, so that you're kind of in control of the messages that you get. Once we have the data in Kafka, one of the consumers of this is going to be our NiFi workflow pumping it into Kudu. Obviously, there could be other storage engines, but Kudu is what we're going to be showing in the demo. And this takes advantage of in-memory processing with, kind of taking advantage of cheaper memory to basically get fast analytics on fast data, meaning you're able to do analytical queries very quickly as data comes in. And to query from Apache Kudu, we're going to use Impala to show how those things can be combined, and it will also be involved in our training and model development. And
the Kudu Impala stack is really well suited for this use case. Kudu was built as to be a storage layer to handle fast analytics, if you will. And so here we have an IoT use case of data streaming in. It's structured data, it has a defined structure. and Kudu also allows us, with the use of Impala or Spark or some of the other APIs, to do full table scans and analytic type queries, and which are well suited for our data exploration and model training as we move into the analytics piece.
So now moving to the actual training and the actual data science piece of this, where machine learning comes in more and more. We're going to use CDSW. It's basically a notebooking tool that Cloudera has built that allows people to easily share deployment types and kind of containerize their workflows so that they don't really butt heads with other people running their other training models. And it also works nicely to be able to choose your own tools that you want to use with this. With the latest release of CDSW, you're allowed to do that, and take advantage of the scale that the Hadoop or platform brings.
And here, as we get into the demo especially, you'll find that we'll contrast CDSW quite a bit with, say, Jupyter or RStudio. And the idea isn't that it necessarily replaces that in every context. However, we do feel from a management of projects and ability to have a multi-tenant environment and things like that, CDSW is really well suited, and that's why we selected it for this architecture.
And then CDSW also allows you to deploy these models. And one of the things where there's a gap is being able to monitor this. And one of the tools that we use internally at phData is something called Pulse. It's an open source framework that kind of gives you this layer, this standard execution layer of allowing you to pump logs to the engine, and it kind of takes care of the background for you. And then you can present visualizations on top of the data that you're collecting in. And we'll show a dashboard that we've built on top of our model for the demo.
Yep, and here, so the key is that, in order to monitor our model effectively, we need a framework that can allow us to monitor metrics as well as logs for traditional heartbeat type style monitoring. Over time, give us an alert framework to do that on, and a visualization component for dashboarding. And the real value, I'd say, versus, say, a Prometheus or Grafana type solution is here with Pulse, it's integrated with Cloudera's security model. And so we get to keep that same level of security because it integrates with Sentry.
So that is an introduction to the tools that we're going to use. But now let's kind of shift gears a little bit and think about how this is actually going to apply to a real world problem and how we can build a solution on top of the tools that we just presented. So what we've built and what we're going to show in our demo is we're taking the persona of a factory GM where machines are taking over more and more. Everything's becoming automated. You're getting less people involved and you're getting more data. So you have to make sure that the data that's coming in is making the right estimate and the right results come out. Otherwise, there's potential here. And every company faces these issues. Like you have Boston Scientific getting fined for heart valve recall, or Union Pacific not really keeping track of their supply chain for their railroad ties and having to recall them and potentially put their customers' lives at danger. So the key here is, there's reputational damage that can be done if things go off track, and if you're not able to monitor and retrain and use things that allow you to do this in a very rapid manner. The other thing that we want to point out is the tools that we've laid out and the model of the way that this data comes in is actually good. We're obviously applying this to a specific use case, the manufacturing of steel plates here in specifically, but it can apply to anything, any type of data set where there's streaming data. It could come from medical devices or transportation or oil wells. It really applies to anything, because at the end of it, the output of that is data. And while we're just looking at a manufacturing plant use case in our demo, that's again, like, it's a repeatable pattern that can be used in many places.
Yeah, and so what we're seeing as an industry is just broadly, I guess I would say, not any one particular industry, but is that there's challenges within every organization that still are unsolved through programming and information technology and traditional solutions. And machine learning and AI give us the ability to solve those and then to integrate solutions into these kind of obscure spaces. And defect detection within manufacturing is just one of those. It's something that there are solutions for today, but they may not be optimal, or they may still really not perform in the way that you want. And so this is just a demonstration of how to apply machine learning to solve that problem more effectively.
Correct. Thanks, Jordan. And so the goal of the GM at the steel plate processing is to basically predict manufacturer defects. There's many reasons and many ways that you can use the data that's coming off the factory line. We could reduce scrap to basically make sure that our profits can go up so we can reduce costs. We can, basically what we throw away. We can basically, we can also ensure that we don't have reputational damage or, customer impact to make sure that our models are fitting what we believe, so that things don't fail or things, are performing the way that they need to go. This is true in the production process and post-production, depending on the line of work that you're in. The way that we're going to do this is the 4 steps that we wanted to highlight, with the title of this webinar. We basically have, an ingestion phase where, we're basically taking that raw data and making a little bit of sense about it. We're going to take a sample of that and we're going to train experiments, and we're going to train models on top of that. Once we've picked a model that we like and that we believe is the most accurate to the state of our world, we're going to then have a deployment method where we're going to have an API that can, basically talk to the model that we've built and give the answers back. And once we've made that deployment, we need something that's actionable. In the manufacturing use case, we're going to actually send that to a QA analyst to make sure that, hey, yeah, that's good. We need a feedback loop here. So part of that is in the monitoring phase, where, is the deployment that's going on up, is if it's not, we need to be alerted on it. We need to visualize like what the feedback loop is. And then, as you make, the reason this is a circle is because that feedback actually goes back into the ingestion phase and kind of starts all over again. And again, since instead of just focusing on the steel plate manufacturing use case, we've seen this in many places across our customers. Medical device company, call center support, where we've had people be able to track and route customers based on their call history and their customer service history to get people to the right place or figure out where they are in line. And with that, we're going to go to our third poll, and here we're going to be asking about the machine learning models that you have in production. Kind of get a sense of how mature everyone is.
Yeah, so I'd say these results, Keith, are pretty consistent with what we see, as we go out and talk to customers. Most people, the majority of people, have 0 models in production. Some may have a handful, but no real consistent architecture around solutions, and then very few have a lot. Matter of fact, I've only run into 1 or 2 outside of, say, Google or Facebook. So.
Yeah, and would you say that that's because the process is kind of dynamic every time, and it's just hard to get back into this flow? It's not a consistent flow.
It's a tough architecture. It's a new space. There's not a lot of tooling to address the actual deployment problem. There's some tools coming out, but they're very narrow focused. And then there's the whole MLOps side of things, which is kind of the mechanism for scaling your deployments, monitoring models, retraining models, so on and so forth. And there's a lot of growth and opportunity in that space.
Perfect. Yeah, definitely fun conversations to have with our customers. So now that we've gone through how we're going to do this, we're going to apply the tools that we use to meet each step of the process. So for the ingestion phase, we brought up Edge Flow Manager and MiNiFi. So MiNiFi is going to be sitting on the factory floor, collecting data from the IoT devices in the plant. From there, we're going to stream the data from MiNiFi into NiFi, which is more centralized. So this bridges the remote gap. And usually in our manufacturing use case, we'll think of this as, you could have many manufacturing plants, so you're going to have many different MiNiFi streams coming into NiFi. And the benefit there is, you can kind of scale that as you need or as you grow. Once it's in NiFi, we're going to then take this information, put it into Kafka, and basically put it into a storage layer. And specifically, that's going to be Kafka so that we can do the analytics on top of it. As we move into the training phase, we're going to use Impala to select the training set from Kudu and then make sense of it inside of CDSW, where the end goal is to basically build a function that the machine learning model can make decisions on based on the raw data that's being fed to it. In the deployment phase, we actually decided to make the function call from the edge device. It doesn't have to be this way. It could be from an internal source, but for the idea of the feedback loop, what we wanted to do was make sure we had something actionable at the manufacturing plant's floor. So what we have is MiNiFi calling the CDSW function that we've deployed, and then once the function has come back, once the determination has come back, if it's an error, we'll put it to Kafka to make sure that, hey, we'll put it on the topic that says, if there's an error, make sure that the device gets routed a specific way, or an application can alert us on that. And also, it just tracks the feedback of what's being set up.
Yeah, and another value here is there's in this hypothetical scenario, this isn't obviously a real manufacturing line running here at the phData offices, but in this scenario, there's realistically going to be multiple machines along that factory line in the factory that need to subscribe to the results of that model, and so Kafka also makes that simpler to handle.
Yeah, that's a really good point. And then the last piece of this is the monitoring, and this is where we'll show Pulse to kind of combine all this with a graphical, basically a GUI to show an updated dashboard of what's being generated into Pulse.
Yep, and again, the challenge with maintaining a model over time is getting that source of ground truth data. And in a manufacturing setting, typically you already have a quality assurance engineer or analyst. And so that sets us up really nicely to collect that ongoing ground truth data. And so in this case, this hypothetical scenario, we're going to simulate having a individual that's providing us with that ground truth feedback on top of predictions we've already made, so that we can continue to monitor model performance and retrain our model.
Yeah, it's a really good point. So now that we've kind of laid out the 4 steps, we're going to have our last poll here, where we're basically going to be asking about what kind of challenges you guys are seeing with your machine learning deployments.
We'll give it a couple more seconds, just since it's a little bit more to read than the others.
That's a pretty good mix.
Yeah, pretty even mix there. I suppose that's about what I'd expect as well. Good to know.
It's very good to know. So now that we've presented this theoretical manufacturing plant use case. One of the, we're going to spend the rest of the time going through a demo to show you what these tools can do, how you actually use them, and show you the live demo or live example feed that we have running in the background here. So I'm going to come out of here. The first tool that we're going to look at here, this is the Edge Manager, the Edge Flow Manager that we had mentioned. One of the features here is we can manage mini MiNiFi devices. And one of the devices that we see here is just this Agent IoT One. If you had a lot of MiNiFi devices connected to this, you could see, obviously different numbers of MiNiFi devices reporting here, but we're basically getting a heartbeat and health from these devices to make sure that everything's functioning properly. When we come into this dashboard here, we're basically designing on a specific workflow, and this dashboard gives us the ability to come in and kind of build up a pipeline. And I'm going to take a processor here and push it onto the pane here, and I'm just going to make a simple like a listener, a port listener. And you can come in and give very generic port 12345 and apply to that. And then I'm going to build another processor where I'm just going to save this to like a file, for example. This is just to show you how you can quickly build a workflow from all of this. And then I might put this in 10.5 just as an example. And now that we've built this workflow, we'll expect to see all of the messages coming into a file on our local system. Obviously, we would probably want to also do other things with it, like we could push to Kafka, we could push to HDFS. I'll show a more complicated one that I'm not going to build live. But the key here is when we build this workflow, I can publish this to the NiFi registry. And when I build it, when I basically publish this to the NiFi registry, I'm doing a couple things. One, I'm versioning it so that I can go back into NiFi registry and look at what I've deployed. And the other thing it's doing is once I hit publish here, it will push this out to the MiNiFi devices that belong to this workflow and restart the process and run the exact thing that I'm running here, meaning it takes up all the configuration and pushes it out to the edge device. So if I come back into NiFi registry, we can see that the version that I just built here, this webinar build, has been saved and versioned off. And if I had another Edge Flow Manager, I could basically copy this and use it in like another environment. So the other tool that obviously builds with MiNiFi is NiFi. MiNiFi is the smaller version of NiFi, but here you have way more tools. You have like 300 options out of the box, and you can build customization on top of it. But again, it's very similar to MiNiFi, where you have some of the same options. So I'm just going to build a process group where basically this is like my little containerization of my workflow. Many people can have different processing groups, and again, I can do like a port listener just to get something very, very quickly up. And then again, save this to like HDFS. So now that I have this built up, very similar functioning between the two services. When I come out of this, I can definitely version this to the NiFi registry, or something that might be a little bit more beneficial is I can relatively easily build another one and import it from the NiFi registry, and you can see that I have two versions of this, where if I wanted to like import this from my previous build, I have a test processing group where I have basically the same piece that I just built, but I've imported it from something that I've saved. And again, you can see the versioning here and see what's been changed. So that kind of gives you an idea of how we would version this between NiFi deployment types, or even maybe from dev to QA to production, something like those. Okay, so to get a little bit more complex, I'm going to show you what we built for the workflow that we're going to show you. And basically, the way that this is going to work is there's multiple steps to the process. We have the MiNiFi devices that we're listening to on the edge, pushing to specific ports here that kind of have a UID that's always collecting data, always listening data from the MiNiFi devices. And we have 3 work streams, and the work streams are basically saving to Kafka, which is, you can see, raw. We're basically saving raw information to Kafka on 3 different Kafka topics. And the reason we have 3 different Kafka topics is we have raw data, we have prediction data that's being generated, and then we have that feedback loop that's going on at the end, the QA feedback loop. And that way, people can just subscribe to different topics as they need if they build different applications.
Oh, thanks. And so here what you're seeing is the final state after the application's being built. But if you can put yourself in the mindset of building this out the first time, initially you'd see that top one, which is just moving our raw data through to Kafka and then on to Kudu. And then the second one, as we go to deploy, we would add in that one, which is our way of calling our API, which you'll see in a minute, to get our prediction and get it back to the edge device. And so that's what that second pipeline is. And the third one is our way of getting ground truth back to our central data lake into Kudu. And so there we're going back the other direction to push bit data back in.
Yeah, good, perfect explanation. And then, so we've published to Kafka, we've published these different Kafka topics, and we need to do something with that information. And here you can see that we're also consuming from Kafka. And then the end result of all this is we want to push it into Kudu. And as we need to take a couple of steps to massage the data a little bit and get it into a form that Kudu is going to like. But once we have the raw data into Kudu, you can see that this is keeping up very quickly and updating how many records we've had in the last 5 minutes. And this kind of gives you a nice dashboard of how many records you should be expecting. So once the data is in Kudu, we can go over to Hue and be able to query this with Impala very easily. And we have a query that basically buckets our information into like 15-second intervals to show us at a high level what our feedback is, what our prediction model is actually giving us, what our machine learning model is giving us. This kind of just gives us some peace of mind to say, yeah, the data is coming across. We know that there's predictions being made, and how, not necessarily how accurate we're being, but that we know that we have all of the pipelines running. And this kind of just verifies it. And the other nice thing is, since it's coming through with Kafka and Kudu, basically, since this data is being updated in the background all the time, we don't have to wait. You can see that this actually updated with new data as it's flowing in real time.
Yeah, and this is a query that we use in the dashboard you'll see later. Ignore the column names there. It's actually not failed predictions. These would be inaccurate predictions, but yeah, we'll show you that in the visualization form later.
So now that kind of concludes like the ingest phase of our workflow, where we kind of have everything into a form that we can start working with it and start doing some analysis. So one of the first things that we need to do is kind of pick a training set and then build a machine learning model on top of it. So if this might be your first introduction to Cloudera Data Science Workbench, but this is kind of the dashboard that you will see when you first get into it. And I have one project, our demo, that I can go into. You can see models that we've deployed. These are actually the live models that we have running the raw data or running on the raw data that's being generated. And then you can see it's kind of just a typical file browser with a couple of options on the side. But let's go into a workbench and start up a session. And when we start up a session, you can see we're starting up just a Python 3 instance. It's a container in the background that's your own, and allows you to also come over here and look at some, basically a file editor and save it out. Now the benefit here is you can always save this out to GitHub and then build another session off of like a Git pull request. So there's really good interaction between this. And I'll let Jordan kind of explain a little bit some of the benefits here, but I'm going to run just a quick example of some markdown that you might run in something like IPython.
Yeah, and the reason we wanted to demonstrate this part is that a lot of people prefer Jupyter and notebooking tools like that. Zeppelin's another. And there's some downsides to using those tools. One is that the main one is that it puts your code into cells, and it's very hard to track state. And so meaning if I create a notebook and I'm running a bunch of different things and I'm playing around, and then Keith comes in, he has no idea or doesn't easily know how I got to the state that I'm in. And so when we develop in an editor like this, it keeps our code in kind of that linear form that makes sense to people coming in. And then also the great thing about CDSW is they are using IPython magic, and so we can do markdown, and we can do inline plotting and things like that. And so that's what we wanted to show you here. So for when you're exploring your data, you still have that option. Now with CDSW 1.6, which was just released maybe a month or so ago, you can actually start a Jupyter notebook as your editor inside of CDSW, as well as RStudio or whatever your preferred editor is there.
Yeah, perfect. And then also inside of this, we can import some Impala, like basically the Impala API, and kind of get some summary statistics that you might be interested in doing some initial exploration of your data sets. And when we do this, obviously this is using Impala, but you could use Spark, or you could use other APIs that allow you to make basically a JDBC connection to Kudu. So here you can see that, yeah, we actually have some data. We want to get maybe some summary statistics to figure out what the min, max, or mean is. That kind of gives us an idea of where our bounds of information are when we're doing some learning or some training of the model.
Yep. And again, this is just to demonstrate to you that how we would use CDSW and the kind of the exploratory phase of training our model. Next, we'll, as you can imagine, we would create a script that actually trains our model. Here's an example. Now this one's quite verbose, and the reason it is because we are looking to set ourselves up for experimentation. And so if you're not familiar with that, there's this iterative process for training a model where you want to track certain accuracy measurements, such as an F1 score or something along those lines. And you want to run this iteratively with different parameters, different weights, different things like that. And so here we set up this script to train our model, and we've parameterized it. That way, when you'll see in a second when we go to the experiments page, we can iterate nicely and track those experiments. And so that's why this is as verbose as it is.
Correct.
And so here at the bottom, you'll also see that we're using CDSW's API to track those metrics, as well as to track our artifact, our model artifact that's output from the training process. So in this case, it's a pickle file because we're using scikit-learn. And so we're serializing that with pickle and dumping that artifact, and CDSW tracks that for us.
Yes, exactly. And these prediction metrics, these metrics that we're tracking are critical in the experimentation process, or basically, iterating your model, because we need to be able to figure out what the data set was that we ran it on, what the model was that we ran it on, and what the variables are that we're passing to it, so that when we get the output, we can basically have something to compare to when we go back in history. And so these prediction accuracy and F1 scores are key to keep in mind, because when we go to the experiments tab in CDSW, you can see that we've run many experiments, but one of the key pieces here is these two columns that we have that are following the accuracy score of the experiments that we've run. And based on the environment that you're in, it can be, one can be more accurate than the other, but we might want to basically look at the history, which we can see here, and the exact arguments that we've passed to figure out what gave us the best score and what we might want to deploy when it comes that time. So one of the things when you run an experiment that comes out of this is you can see the output that was built, basically your artifact, the time that was passed, the arguments that were passed, the script that was passed, and obviously the metrics. The other thing this gives you is exactly what was run, the logging of it, the Docker build of it. Another nice thing is if you want to run this again, you can kind of you can basically kind of run the exact same thing based off the script. We could also do other things where if you want to change the variant arguments here, it's pretty easy to do because it copies it for you and then just keeps track of it.
Yep, and so this is a key component of that. I referenced the ML DevOps, MLOps framework earlier, and this experimentation flow and the lineage of tracking the code, the binary output, the model output, if you will, the metrics, the parameters, all of that is really critical, and this is just a nice interface for doing that. And matter of fact, when we're ready to deploy the model, we can just select the file there, add it to the project, and then redeploy, which transitions us nicely into the how we deploy a model.
Yeah. So let's go into one of these models that's actually running. When we have this, there's obviously, this is pretty verbose, but gives you kind of like an example of way that's going to run, a response that you might get from it, and it gives you a little box to say, what might a test input be. When you run it, you can basically hit the API and see exactly what response will come back from it. Gives you a little bit of a testing ground, but it also gives you, kind of the same thing that experiments had. You can see where things have been deployed. You can see the builds that have been run. It does have a monitoring page that shows you how many messages we've received. You can see that we have 2 replicas of this, and both have had about 50,000 messages received. That's kind of just a baseline to make sure that things are running. And when we get into the Pulse piece, I think that it will be a little bit more obvious what the difference is.
Yeah, and so one thing I'll say on this dashboard here is, while it's great and it gives us the errors, whether and the errors here are whether they're 400s or 500 status code, HTTP status codes. The downside is there's really no hooks to get into this programmatically, and so if you're wanting to trigger alerts or things like that, it just doesn't provide us with that, and that's why in our application we're hooking our logs also out to Pulse, and you'll see that later.
Yeah, thanks, Jordan. And then one of the things, just to kind of show you what it might take to deploy a new model, we basically have built a file that's similar to the experiment file, the experiment.py file, except this is using the artifact from the experiment file to basically build an API and then call a function inside of it. And then you can select the kernel that you need, the Docker size that you need, and the number of replicas in case it's absolutely necessary. And the nice thing about this is when you give example inputs and outputs, you're basically self-documenting the model that's out there so that when people come in, they can see exactly what's being expected of them.
Yeah, one clear distinction I'd like to make here is that even though we can select multiple replicas, CDSW's API deployments are not highly available. And so meaning, as an example, if you had to make an update to the model, it actually is going to bring down that API and then, a minute or two later, relaunch it. And so just something of note, as you architect your application.
So I'm not going to actually deploy that, but just to kind of reiterate the monitoring here, like obviously there's the high level API metrics of how things have been processed, but one of the things that we have in our script here is we have the call to Pulse, and the idea is we want to build a dashboard on top of the metrics that's being logged to Pulse. And this is the example dashboard that we've built, where all the information that's coming off the manufacturing line, it's telling us the predicted faults based off the raw data that we're seeing. What I was saying was, we basically have a couple of ways to plug into that feedback loop where we're showing like a trend over the last hour of how many errors we've collected and what the analysis from the QA person is on their line. And it gives us like kind of an idea of how we're trending. At the bottom here, this obviously is this is a lot of information that's coming across, but you can see the kind of the light blue is the number of requests, and then there's a darker blue at the bottom that's showing us the number of inaccurate predictions. And then there's obviously this dotted gray line that goes across that's kind of doing our trending of how much information is, or how many inaccurate predictions we're having. And the benefit of this is we can set up basically alerts on maybe the number of errors that have been generated in the last hour, or these trend lines, to say, hey, if we go above some threshold, we want to get an alert about it and make sure that our model doesn't need to be retrained, or that we're getting good data along the pipeline, where we can look at the logging in the background here to see if there's anything that's off about our model. It's weird UI bug there.
Yep, and so here we just wanted to demonstrate to you kind of some of the capabilities of Pulse. Of course, this doesn't show you the alerting framework piece, but Pulse is, again, a framework, and Arcadia is just a visualization tool that we happen to use on top of that. But you could, potentially use any number of other tools here. And these are just some examples of the types of things we might plot so that we can monitor that model. And so, as Keith mentioned, we're monitoring the number of inaccurate predictions there at the bottom. As you probably guessed, this is basically demo data with noise added to it along the way, and so that's why it looks the way it does. But in the real world, we would expect to see trends there, and eventually, some sort of trigger to retrain our model.
Exactly. And so that concludes the demo that we have. Kind of like to open it up to questions if there are any out there. I will say that we also have a piece of this documented on our GitHub, and we've done this demo with some other tooling to our customers out there. And if you have any questions around that, we're happy to answer those.
Yep. And so if you do have a question, please ask it in the chat there, and we will start to answer them. And so there was a question about experiments and if you can use Scala. So the answer is yes, you can use Scala and CDSW, and you can use Scala running an experiment.
Yeah, CDSW allows you to do Scala or Python or R or almost any. I shouldn't say almost anything, but many different languages.
Yep. The other question was, let's see. Yeah, so good question. So question here is, who on our ML team is or should be responsible for monitoring models? And that's a great question. And so what we found is that there's a need to have basically an operational support team that not only monitors models, but monitors hardware or infrastructure, software services. There's a lot of things that go into making sure that a model is running successfully. Data quality included. And so there's usually a team, and this is how we've seen this done successfully, and a service that phData offers is a team that runs that operations component. And so I guess if you're in early days, oftentimes I've seen that the data scientists have to do that on their own, and no one's happy in those situations. And so you'll want a operations team for that. Where is the GitHub URL? Keith, if you have that easily available, maybe you can drop it in there, but I believe it's also in the email that we'll send as a follow-up.
Yep.
And if not, you can Google phData GitHub, and it would be in there. And then let's see, is platform monitoring different than application monitoring? The answer to that is yes. There's definitely some overlap in how you go about monitoring platform/applications. For example, in Pulse, in this case, you could log both application metrics as well as CPU utilization, things like that. And so in that sense, there's a distinction. Now, with machine learning, we also have statistical performance monitoring. And so that's even different from application monitoring. And there, we're monitoring things like data quality. We're monitoring things like allowed values, distribution of, say, age, as an example, if that was a variable, or in this case, we have ground truth data coming in, so we can actually monitor feedback in that sense. If it's forecasting, you might monitor against your actuals with some sort of trailing time there. Any other questions? Give it just a minute. Well, great. Then with that said, we will be, just a reminder, we'll send out that email with the survey after this call later this afternoon. So be on the lookout for that so you can get your ebook. You will want to go through that survey and get to the end so you can get the ebook. And if you have any questions, feel free to reach out. And I'm sure there will be contact information in that email as well if you'd like to reach out. But thank you, everyone, for joining.
Thank you, everybody.